Hi, I'm Greg Benedis Grabb, and I want to talk to you about programmable sensors for sense making in the science classroom. Come join us at the NSTA conference in New Orleans on Thursday, and we'd be excited to see you there. The aim of this session is that you will get to experience the sensor immersion curriculum, which includes storyline pedagogical strategies, computer science, similar to the way professional scientists use computers, and a way to make investigations personally meaningful for all students. We're going to talk a lot about storylines. Um, and we're also going to see how it connects to using it specifically with computational thinking and computing devices in the science classroom. Um, in this session, you're going to learn all about the unit. We're going to experience some of it hands-on, and we're also going to show you all the different materials and how to navigate them so that you can get started using this unit right away. Our storyline involves a series of lessons, and you're going to get to see some of the lessons in a hands-on way during the session. One of the things we're going to focus on is an anchoring phenomenon routine, where we're going to experience a phenomenon. We're going to do some noticing and wondering. We're going to do a driving question board. We're going to get to draw an initial model and talk about how some effective ways of using modeling in connection to computational thinking. And then we're also going to talk about how to use that driving question board throughout the unit. We're also going to talk a bit about the importance of student hat work and really getting in the perspective of your students as you engage in activities to help you kind of think through how you might use some of these materials. That will also lead to some really important conversations about the kinds of decisions that we make as teachers. And so we'll move back and forth between these two roles. The sensor immersion unit is really exciting because it shows how we can use a simple device, a simple inexpensive device like the microbit to collect data and make scientific investigations more meaningful and connected to students' communities, and show them how they can use this kind of device to communicate as well. Our anchoring phenomenon starts with a video of an example from San Francisco, and then we bring in a teacher-made device that there are directions on how to create it in the materials. And we do some noticing and wondering, and we'll get to experience that device during the workshop, and do this routine of noticing and wondering. We'll also have you create your own explanatory model, and we'll talk a little bit about how to support students in creating those models, and where to go with that. And we'll also take you through the drive and question board routine, where you will write 3 to 5 wonderings on stickies, and then we'll bring everyone up to the front, and get to put some of these ideas on the driving question board, organizing it and putting it together as we go, so that we can have a guiding document to take us through the whole unit and really make students at the center of that inquiry process. And then we'll engage in some teacher discussion about how we facilitated the anchoring phenomenon, the driving question board, and also talk about how that experience felt as a learner during the workshop. And we're hopefully going to have time to do some exploring with the microbit and the Make Code platform that you can see here. And if we have time, you'll get to make the flashing heart tutorial or other ones if you have experience with microbit already. And so that'll be a lot of fun, and we will bring microbits so that you can have that experience. And again, you'll get access to all the resources. There's a whole folder of activities, and they include things such as debugging, flow charting, pair programming, and more. So come to the workshop and you can find out more. We also encourage you to come visit our website, um, on Inquiry Hub and find out more about our materials. And in addition, we have some other units on there, a mold unit, a maglev unit, and ecosystem. So we can talk about that as well. And so we have a lot of curriculum materials. And finally, I'd like to thank the National Science Foundation and the James McDonald Foundation for funding some of these projects and making these things possible. Thank you so much.